All right, so what's W then? If Q is heat and it's measured in joules, work. What's it measured in? Also joules. I'm adding two things. They both better be measured in joules. What about potential energy? Let's go through that one. What's M? What's it measured in? G?
Gravity.
Does it have a number?
9.8.
9.8 what?
Meters per second squared.
And what about H?
Height.
It is height. What's it measured in? So do you see if I multiply these? Now I have meters times meters, that's meters squared. I have it divided by seconds squared, and I have it over kilograms. So what are my units for potential energy? So I would have kilograms times meters squared over seconds squared. And what did we say that was equal to?
Joules.
So potential energy is measured in joules. And I proved that because I know if I multiply kilograms times meters squared over seconds squared, I get joules. All right. Quickly, KE, what's M? Mass in?
Kilogram.
Yep, what's V?
Meters squared over second squared.
It's velocity, and when I square it, it's meters squared over seconds squared. But what is the unit for just V? Meters per second. All right, let's do the Q one. Q, you told me before, is heat. What is M, C, and delta T? Mass. Okay, M is mass. What would it have to be measured in? In general, it has to be measured in whatever C is measured in. C is the specific heat. This is a brand new thing unless you've taken physics. All right, you go to the pool. It's a really hot day. Stop writing. Time out. It'll still be up there. Don't worry. Okay, you go to the pool. It's a really hot day. Are you going to lie down on a sheet of copper or on a towel?
Towel.
Why?
Copper.
Okay, copper gets really hot really quickly, right? Have you ever put aluminum foil in a toaster oven and then realized that you can take it out right away and it won't burn you?
Yeah.
So what do you know about things like aluminum foil? Does it get hot quickly or slowly?
Slowly.
If you put it in, you ever, like copper, think about it. You just told me copper got really hot. Okay, so then what happens? Does it cool down quickly or slowly?
Cool down quickly.
Okay, so those kinds of things heat up really quickly and cool down really quickly. Then I have other things like a towel or a blanket or water that takes longer to heat up and longer to cool down. Specific heat tells me how much energy it takes to raise 1 gram of that substance by 1 degree Celsius. So to raise copper 1 degree Celsius, it's really quick. It doesn't need a lot of energy. To raise water 1 degree Celsius, so you have 1 gram of water, it takes, am I going to be able to fit there? This means I have 1 gram of water. And say it's at room temperature. It's at 22 degrees Celsius. I have to add 4.18 joules. And that will take my 1 gram of water and turn it into 23 degrees Celsius. If I have something like a metal, all right, ready? It's how much energy you need to add. How could we make water go from 22 to 23 degrees Celsius? What could we do? How do you make water temp increase? Okay, I put my water on the stove. What am I doing when I put my water on the stove? I am heating it up. That's all about Q, right? But I'm not going to boil it right away because I know water takes some time. I need to keep adding energy. Remember, Q is about energy. So if I have a lot of water, do I need more energy?
Yes.
Okay, that's where mass comes into play. Because if I have more mass, I'm going to need more energy, right? If I want to change the temperature more, instead of taking it from 22 to 23, I want to take it from 22 to 100. Do I need more energy?
Yeah.
Yeah. So that's where delta T comes into play. It's the change in temperature. So the idea is water is different than copper, which is different than aluminum, which is different than ethanol. They're all different substances. They all need different amounts of energy. This specific heat is in a table. It's a known quantity for any substance that you want to look up. So I can tell you water is 4.18. That's the one you should memorize. Everything else you can look up in a table. It's going to be given to you. So I want to try a few specific heat problems before we finish the table. Turn it off.